If you're trying to produce traces, metrics, logs without any change in your application code, then this episode is for you. Welcome to Is It Observable? Today's episode is part of the OpenTelemetry series where we already covered several episodes. We had the introduction to OpenTelemetry, what is OpenAMP, how to observe your Kubernetes cluster with the OpenTelemetry collector, the value of the OpenTelemetry operator, how to instrument your code, how to build custom metrics, and so on. Today's episode will be focused on presenting a solution that will produce telemetry data out of our Kubernetes cluster without making any change in our code. And I'm referring to Odigos. If you enjoyed today's content, don't forget to like and subscribe to the channel. So let's see what you're going to learn out of this episode. We'll start with an introduction reminding what are the various solutions available to produce observability data from our cluster. We will then present the solution Odigos, and then we will see the various options to configure Odigos. We will have an interview of the CTO co-founder of Kival, which is the main contributor of Odigos. And as usual, we'll jump into a tutorial. What kind of options do we have to instrument our application? Well, by following this channel, you may know a couple of options. There are several ways to instrument our code. Starting with the non-recommended option from our community is using OpenTracing. Because OpenTracing, it's deprecated and being replaced by OpenTelemetry. So it won't be the preferable option. Then the second option is using OpenTelemetry, of course, with manual or auto instrumentation, and of course the collector to collect logs, metrics from StatsD, Prometheus, and so on. Or using a vendor agent that will instrument the application, the processes, the resources, collect logs at the same time. Or last, using eBpf technology to collect hosts and profiling information of our application. There are solutions like Pixies designed for Kubernetes that will instrument and observe the cluster locally and then send the telemetry data to another backend. Instrumenting our environment is one thing, but you need to send the collected data to one or several observability backends. That is the reason why we often rely on the OpenTelemetry collector or FluentBit to use them as a gateway with our observability backends to report spans produced by the deployed applications, but also logs and metrics from our cluster. But those agents require configuration, creating a pipeline. And creating a pipeline is a task that we need to manage by adding the right receivers to collect the desired signals, process to modify or enrich our data, and last, export to send the data to our observability backends of our choice. Currently, there are several solutions available to simplify the management of our agents. So Pipeline focuses on managing the collector pipelines, the updates of our agents using the OpenAMP protocol. If you want to learn more about Pipeline, check out the episode dedicated to Pipeline and OpenAMP. There's also Calyptia, designed to manage our FluentD and FluentBit pipelines. But producing traces out of our code still required to slightly modify our code, except if you're using the OpenTelemetry operator that can inject the right auto-instrumentation library in our pods. If you want to learn more about the OpenTelemetry operator, check out the episode about it. Otherwise, Kival is working on an open source solution that will collect metrics, logs, instrument our application without changing any application code. This solution is named Odigo and is specialized for Kubernetes. Odigo is an open source observability control plane that is able to instrument our code using OpenTelemetry, collect resources, metrics from our Kubernetes cluster, collect logs from our cluster, manage our OpenTelemetry collector, manage also the way we want to send our telemetry data to one or several observability backends. So how is Odigo able to instrument our code without any code change? Well, if you paid attention, I deliver an episode related to OpenTelemetry operator that can manage the deployment of our collectors and inject instrumentation library in our code. The OpenTelemetry operator is great, but currently it supports the auto-instrumentation of Java, Node.js, Python, and .NET. Odigos supports the similar language, but is also able to instrument Go by using the eBpf Go instrumentation library. So what is Odigo? Odigo is currently a Kubernetes operator composed of several components. There is an instrumenter, the autoscaler, the scheduler, and last, the UI. The instrumenter, as you may have understood with the help of the name, it will be in charge of instrumenting our application by injecting the right auto-instrumentation library. Odigo deploys also a daemon set named Odigo Odiglet. This workload injects eBpf program to identify the language of our workload, the environment variable used by our workload, and the processes used to launch the application. With the help of this information, Odigo will create a technical CRD named Instrumented Application that will use to reschedule our workload with the right instrumentation library. The scheduler, briefly mentioned about it reschedules our workload in case it is already running or if we have made some changes in the environment variables or the process to start the application path. Autoscaler. We have an autoscaler component that will be in charge of deploying the various OpenTelemetry collector and scale them if they are heavily used. At the end, Odigo deploys two distinct collectors. One called the gateway that will be deployed to send the data to each backend that we have defined. And the other, the Odigo data collection that is collecting logs, metrics from our cluster. So we will have two collectors running in our cluster. The first one will be the standard for all our cluster, collecting traces, metrics, and logs, and exporting everything to the other collector, the gateway collector. The other collector will act as a bridge with our observability backends. If you're curious and you want to see the collector pipeline generated by Odigo, you can still look at the config map used by each of those collectors. The UI. The web UI allows us to configure Odigo. Again, this is optional because we can technically configure everything using the CRDs introduced by Odigos. Configuring Odigos will go through three steps, actually two. Step one, define the workload or the namespaces that we would like to instrument with the help of Odigo. Step two, define the destination where we would like to send our data, which backend. Step 3, Odigo will deploy automatically the right collector instances to send the data to our observability backend. Like mentioned, the configuration of Odigo can be done by using the Odigo's UI. But all the settings can technically be done using the CRDs and annotations. If you want to instrument a given namespace or deployment, stateful set, daemon set, and so on, you simply need to add the following labels. Here it is, Odigo's instrumentation equal enabled. And on the opposite, if you don't want to instrument a particular workload or component, you simply need to add the annotation. Here it is, so workload Odigo instrumentation disabled. Next, if your application is already instrumented using OpenTelemetry, then you won't need to inject any Odigo's instrumentation in your workload, but use the OpenTelemetry collector deployed by Odigo to send the produced telemetry data from your application, and then it will be forwarded to the right backend. To configure Odigo, you will need to define a destination, either from the UI or using CRDs of Odigo. Odigo introduced several CRDs. So we have the destination, defining where we want to send our telemetry data, the instrumented application, listing all the deployment or daemon set or whatever instrumented by Odigo in a given namespace, for example. There is the collector group that will define the various collector that will be deployed by Odigo. From the three CRDs, we will probably going to only configure the destination object to define where we want to send our data. So let's have a look at the destination CRDs. So here is an example of a destination. So here I'm sending to Dynatrace. You can see that the destination takes a name and then the settings related to the observability backend, the OpenTelemetry signals supported by the backend, and the settings specific to the destination. In the case of Dynatrace, you need the Dynatrace URL because the URL at the end is not sensitive information. This information is available as a data. The other settings required is the API token that we probably don't want to leave like this in the CRD. In this case, this data is considered like a sort of password, so the data at the end will be stored in a community secrets named, in our case, Dynatrace. Every solution has their own requirements, so you will need to understand the settings required before being able to create your own destination CRD. Here is the list of the various destinations available as of now with Odigos. So it currently supports Datadog, Grafana Cloud, New Relic, Splunk, and many others. The instrumented application CRD will not be configured by ourselves, but Odigo is creating it and updating it to use it as a reference to inject the right instrumentation library in our pod. Last, the collector group defines the number of collectors to deploy. There are two types of collectors in Odigos. There is the data collections and the gateway. You will always have one data collector and one or several gateway collectors that will forward the data to the right observability backend that we have defined. Out of the two instances of the collector, there would be one Kubernetes service that would be used to send our telemetry data, the Odigo gateway. That means that you can use this endpoint to send your OpenTelemetry data from your application already instrumented with OpenTelemetry. In order to get more details related to Odigo, I think it makes more sense to call Eden Federman, co-founder and CTO of the company Kival, which is behind the project Odigo. Hi Eden, how are you?
Hey, great to be here. Thank you for having me.
So I spent a couple of days playing with Odigos, and I think there are lots of great things behind this project. So I have several questions related to the project and the product updates. So before we jump to all those questions, could you introduce yourself to the community?
Hi, I'm Eden. I'm an engineer for the last 15 years now. I created a couple of open source projects. For example, I created a project called kubectl Flame, which is a popular profiler for Kubernetes. I really love everything related to eBpf and OpenTelemetry. And I think that most notably, I created the automatic instrumentation for Go applications, which is something that we later donated to the OpenTelemetry community and is now being developed as part of the Go automatic instrumentation special interest group. And as I said, currently I'm the co-founder and CTO of a company called Kival.
So you're the co-founder of Kival, and Kival is at the end the main contributor of Odigo. So maybe it could be great that you explain the story behind your company and also, related to the topic of today, the story behind Odigo. Why did you decide to build such a solution?
Basically, when we first started Kival, our original idea was to leverage the great data that exist in something like distributed trace and generate with it dynamic documentation for code. And the more we spoke with potential customers, the more we realized that most companies have yet to adopt distributed tracing because it requires such an effort and complexity that includes like tons of code changes, in addition to managing all those OpenTelemetry collectors. So basically, we figured out that in order to make distributed tracing mainstream, it needed to be an extremely easy to use. So we pivoted and we started to working on our open source project, Odigos.
Is Odigo your main open source project, or do you have any other initiatives related to open source or OpenTelemetry?
Yeah, so as I said, we started with the Go automatic instrumentation using eBpf. This is something that is donated to the OpenTelemetry community. This was our first open source project. And the second project is Odigos, which is Most of what we are doing right now, we are just focused on this open source project, and really our main mission is just making OpenTelemetry much easier and more accessible to use.
To prepare this episode, I have used Odigo version 0.15, and I guess there's plenty of features in the backlog. So could you share potential product updates, or where is Odigo heading to?
The community is working on some really great features. The first one of them is we are completely redesigning and rebuilding our user interface with a more focus on simplicity and ease of use. This should be out in the next couple of weeks, and Odigos will look completely different. The second thing is that we want to basically make automatic connectivity to existing observability backends. The third feature is basically everything related to better collectors management, which includes adopting protocols like OpAmp and extending the autoscaler capabilities that exist right now. In addition, we are constantly adding more and more destinations. Last time that I checked, we supported over 20 destinations, and I expect this number to double in the next couple of months.
So for the moment, you're supporting metrics. You're collecting them with the help of your own eBpf component, and also the one that we have produced from the OpenTelemetry agents. You're also collecting traces produced by the OpenTelemetry auto-instrumentation agent, and you automatically collect logs from the cluster with the help of the OpenTelemetry collector. Are you planning to add the support of continuous profiling as well?
So regarding continuous profiling, we are closely monitoring the development in the profiling workgroup in the OpenTelemetry project. And as soon their job is ready and there is something that we can use, we will definitely add support in it in Odigos. Basically, we try to adopt every new project that is coming to the OpenTelemetry ecosystem and really make it easy to use and include it as part of the Odigos control plane.
So you mentioned something that I really like. It's the OpenTelemetry protocol. I think it's really exciting protocol helping us to manage all our telemetry agents. So you're providing a way at the moment of configuring the collector pipelines for your users without any need of touching any YAML files. What do you have in mind with the usage of the OpenTelemetry protocol?
I agree. OpenTelemetry is a great project, and I think it has a lot of potential. And in general, the feedbacks that we are constantly hearing in the Odigos community regarding collectors management is that it should be much more easier. So once the support for remote configuration is added to the OpenTelemetry collector via OpenTelemetry, for example, we will definitely implement it in Odigos. And I think that currently we are using, we do restart for the collectors and we change config maps in order to keep the collectors up to date with all the recent configuration changes. And I think that moving into OpenTelemetry will make the entire experience much more smooth.
At the moment, you are building the collector pipeline based on the data that you are collecting. If, for example, I'm using Solace to produce telemetry data from the event mesh, to get these extra details, I need to use a specific collector receivers. Today, I can technically update the generated pipeline by modifying the config map used by the gateway collector. But are you planning in the future to have a UI similar to pipeline where you could basically drag and drop boxes to build your custom pipeline?
Yeah, definitely. I think that in general, OpenTelemetry collector is an amazing technology. But I think that as OpenTelemetry gains more and more tractions and more features and receivers and processors and exporters are adding, my feeling is that configuring the collector via this YAML file is going to be more and more complex. So Odigos, with its intuitive UI, and as I said, we are currently redesigning the UI completely from scratch, is going to be in a great position to simplify this configuration file and making the configuration of the OpenTelemetry collector a much more simpler task.
Odigo is relying on eBpf to discover lots of things in the cluster. All the instrumentation of your application, the metrics produced from your cluster are done through the eBpf program. I was wondering if you could automatically detect, for example, the presence of a service mesh like Istio and suggest the right Istio configuration to enable telemetry data, and then configure your collector to collect those extra details. Or the other use case will be related to Prometheus exporters. Your eBpf component should be able to automatically detect Prometheus exporters already available in the cluster and suggest to the user if they would like to collect those metrics from there. Have you already thought about those use cases?
Yeah, definitely. It's something that we're constantly thinking about. And as I said, I think that everything related to automatic detection of existing infrastructure, things like service mesh, or even like existing observability backends like Jaeger or Tempo, is on our roadmap. And like not just Istio, by the way, we're also going to support Linkerd as well. So basically, after Odigos will detect different existing components, it will automatically configure the OpenTelemetry collector to send data to your existing infrastructure. It can be service mesh, it can be OpenTelemetry backends, and all of this without require any additional configuration from the users. So we basically just need to confirm it in the user interface that you want to send traces to your already installed Jaeger instance, for example, and Odigos will do all the rest. So yeah, again, this is something that we are constantly thinking about how we can make the overall experience much more smooth and require less information from the user.
So you're mainly focusing on making the life of the user simpler, where they don't need to touch anything to get observed data from the cluster. Are you planning to provide features for more advanced users where they could touch the pipeline by adding extra receivers or processors?
Yeah, so I think like we want to start with a very opinionated approach. We want to get you started on OpenTelemetry and distributed traces as quick as possible with your existing infrastructure, with your existing systems. And for advanced users, if you want to modify the defaults of Odigos and play and change the ways that Odigos do all those pipelines and all those configuration changes, you can completely do that. But like our way of thinking of it is that like we want to start simple. We want to let as many people as possible to enjoy OpenTelemetry. And if you want to do some more advanced stuff, Odigos will get out of your way and will let you configure and do whatever you need on top of the opinionated approach that we're presenting.
So you're currently relying on your collector distro. Do you have an options to use a custom image of the collector?
Yeah, so basically the distros that we use today is just like the OpenTelemetry collector contrib, where we selected all the exporters that are currently supported in Odigos. So it's not like it has some additional keyval code or something like that. It's just like a more minified version of the big OpenTelemetry collector contrib. And basically everything in Odigos is open source. The collectors are open source. The instrumentation libraries that we are using are all vanilla OpenTelemetry. All the data is produced in the OTLP format, and definitely, if it's not already supported, you can. It's something that we will definitely add in the future to allow you to choose your desired image for the OpenTelemetry collector. And yeah, we want to again start as simple as possible. But if you want to change some sort of configuration, we want to stay out of your way and let you do any configuration change that you wish.
So you're providing Odigo as an open source solution, but I guess in the future, Kiva will provide like a managed versions of Odigo?
Yeah, so as you said, yes, our way of monetization will be a managed version of Odigos. But again, we are currently just focused on the open source version. I think like for the at least 1 year ahead, we're just focused on making Odigos open source, the best way to work with OpenTelemetry and really just make it very smooth and very good experience. After we've done that, we will think about how we're going to do the managed version, but right now we're just focused on the open source.
How can the community reach out to the project to get more news?
There are a couple of ways. First of all, you can open a GitHub issue or pull request. We are always looking out for new issues and new contributions. You can also check out our Slack. We have a pretty good, pretty active Odigo Slack channel. And you can also read on the Kiva's blog. We constantly post about new updates and new design decisions that we've made about how we are building Odigos. So
I think we covered most of the questions that I had. So thanks for taking the time to answer to all of my questions.
thank you. It's been great. I hope it was good.
Perfect. Thank you. See you. Bye. In this tutorial, we will deploy Odigo to report observability data collected by Odigo into Dynatrace. We will deploy the microservices architecture, the hipster shop, and we will let Odigo instrument it automatically. Then we will use the OpenTelemetry demo application to send produced data, metrics, traces to the collector gateway. For this tutorial, we'll need a Kubernetes cluster, the nginx ingress controller, the hipster shop, the OpenTelemetry demo application, a Dynatrace tenant, and of course, Odigo. Like every tutorials that we delivered at Is It Observable, there's always a GitHub repository, and here you're looking at the one related to Odigos, obviously. So like mentioned, a couple of requirements specifically for this specific tutorial. If you need a Kubernetes cluster, like mentioned, so you can use JKE if you want, but you can use your own flavor if you want. If you don't have any Dynatrace tenant, you can still start a trial. So if you click on trial here, you will fill in the email and you will get a tenant in a couple of hours or minutes. Then, once you have your Dynatrace tenant, a couple of things we need to do. We need a Dynatrace token because we're going to send the various observability data collected by Odigos. So if you go to Dynatrace, you have to go to access token on the left menu, and you will have to create a new token, and you will simply have to type here, give a name, of course, to the token, but you will have to type ingest. And in this case, we are ingesting logs, we're ingesting metrics, and we're ingesting traces. So we will select those three scope, and then you will create. You will click on generate token, and like mentioned in the previous episode, this token will display once. So please save it and into a variable that is described in the README file. And the second variable that we need to create is the Dynatrace tenant URL, which is here. So make sure to take this value, the entire URL until .com without the slash, and save that into the variables. Once you have done that, make sure to clone the repo and then run this deployment file. So this deployment file will deploy most of the component that we need within this cluster. And let me show you what you are going to get. So if I bring the terminal, here it is. So first of all, if I do kubectl, you will obviously have a couple of namespaces. So first, it's the hipster shop, because hipster shop will be the one used to let Odigos instrument the application. Second thing, we're using an ingress controller. Is not necessarily required, but it's just to expose those applications out of the cluster. We used ingress for nginx for this. We will have the hotel demo. So hotel demo is deployed. It's already instrumented, producing metrics and traces. So we will see later on how we can configure an existent instrumented application to send the data to Odigos. And of course, you will find the Odigos system namespace that holds the Odigos component. So in hipster shop, I'm going to not go show you, it's just the traditional pods, but we can still see it. So you can see that we have a couple of services, a couple of pods running there in this namespace. And if we do the same thing, we should have the hotel demo. Same thing, we have the various, plus, I don't remember the number, pods running here for the hotel demo applications. So now, most important, what do you have in this namespace Odigos? We will have a couple of different things here. We will have the Odiglet, so the daemon set with the eBpf programs, the autoscaler, like explained, the instrumenter, the scheduler, and last, the UI. So the second thing, though, now that we have everything deployed, what we're going to do is to have access to the UI of Odigo. So I didn't expose it through an ingress for obvious reasons. So I'm just going to do a port forward, so then we can reach out to the service. So here, I'm going to apply this command. So that will expose the Odigos UI to localhost. So if you look at localhost on the port 3000, we should arrive to the setup of Odigos. So the setup of Odigos will go through several steps. First, we're going to target which application we would like to instrument. And in our case, it's obviously the Hipster shop. So we can say Hipster shop, save. Then second thing, it's going to suggest the Dynatrace destination for in our case, but there's others available. And here we'll give a name. So here it's going to be Dynatrace. So it's just a technical name for Odigos. And then similar to the token that you have pasted, you will put the variables that you had that you initially had in your cluster. So let me do that. Now I'm pasting my without the slash my tenant URL, and then I will paste my token as well. And you'll see that it's going to be a password, so you won't see the API token. And as a consequence, because it's a password, Odigo will save the value into a secret. So let's create the destination. And when doing this, so now we can see that we have the destination set for trace metrics and logs, Dynatrace. We have the sources of application. He already discovered which technology we are interested in. And then you can see that there is some collectors deployed, and you can see that the 2 collectors are already deployed. So at the end, this is the instrumented application CRDs. This is the destination CRDs, and this is the collector CRDs. So if you are just a bit curious, stop this, but we can look at the destination in the Odigos. We can see that now we have the Dynatrace CRD created. What we can see here is that we have a couple of things deployed. We have the Odigos data collections deployed as a daemon set. So we can see we have two of them, one per node. And then we have the gateway, which is the one that will be used to send the information. And if you look at the config map related to those names, to those in this namespace, we can see that we have the one config map holding the pipeline for the data collections and one for the gateway. So if you look at here, we can see that it's doing a couple of things. You can see that there is an exporter. It's sending that to this exporter here. And you can see that there's no processors used, just the batch and the Odigo resource name. Health check is enabled in that page. And then you can see that we use the file log to collect the logs. And if we scroll down, we can see that it's using the kubelet stats to get some stats from kubelet. It's receiving OTLP because the application instrumented will be sent to this collector. And you can see that there is a one log pipeline, one metric pipeline, and one trace pipeline. And then the other one is obviously much more simpler because it's going to just receive the data from this collector to then send it elsewhere. So once you have configured Odigos, you can go to distribute traces or services. It's the same thing. In fact, you can see that we're also receiving OpenTelemetry demo applications traffic. I'll explain why, because you see that when it deployed, I already made a reference to the collector of Odigos. So that's why we are getting things. So here we can see that we have a couple of information or traces that has a reference to the hipster shop. So those are the one from the hipster shop. The problem that in this demo is that the hotel demo and the hipster shop has the same service naming. So I should have changed the service naming to at least see services with different names. It will be easier for us to see the data. So this is a service coming from the hipster shop, as you can see here. And if you look at the logs, there is a mapping with the logs, and you can see that it's mapping with from a log coming from the heap shop. So the mapping from the log of that specific container and the trace is done automatically. First of all, through this feature of Dynatrace, but the second is that Odigo is collecting logs and traces and matching it on the collector. So that's how we're getting all those informations. So that's from the pure traces aspects. We can see that I didn't do anything. I just did the configuration of the UI, and bam, I got some traces. The second thing that we should have now, if you go to logs in Dynatrace, now there's nothing configured in this tenant except Odigo, and you can see that this is coming through. So then I can basically look at maybe the cluster name. No, maybe not cluster name, because I don't think I gave a name, but here we can see that we have our Odigo systems, hipster shop. Those are the ones that are generated or collected through this collector. So if I run the query, I will only look at the hipster shop. And for each log line, I have the various attributes, the pod ID, the pod name, of course, the log itself. So I have plenty of different information that is stored here in these logs. So same thing, without anything, I just received logs. Second thing that I have here is in this tenant, like I said, I have nothing deployed. So I have the default Dynatrace metrics, but if I go to the back of this metric lists, I have the couple of metrics coming from the hotel demo application that is already standing. In fact, I didn't change the endpoint. So if you enable the instrumentation, you will get that. But now what you can see here, we have already also some metrics. So we have the Kubernetes node memory page folds, code memory. So this is obviously coming in my cluster since I have enabled Odigos. So you have some information about how the CPU node, CPU utilization, you can see how it goes. So you get plenty of metrics already without doing anything related to the containers, to the Kubernetes nodes, to the pods, so at least you get an understanding of what's going on. If you look at the services in this namespace Odigo system, you will see that at the moment there is a UI, but there also a gateway, which is the one that will be used to transport the observability data that Odigo has collected through the data collection collectors, and those are being sent to this other endpoint, Odigo Gateway, that will receive everything and then send to our final destination, in our case, which is Dynatrace. So which means if I have that service name, and which in fact technically when you deploy the scripts, I already have run the script, I already configure the application hotel demo app. So if you click on OpenTelemetry demo, you see that on the deployment YAML files, if you scroll up and scroll down in the OpenTelemetry demo application, the reference of the collector that will be used to send the data is under an environment variable on each of those pods. And you can see here there's hotel collector name. So here you can see that I'm already referring to Odigo's systems namespace, which is the one Odigo Gateway, Odigo systems, and the service. So it's basically already configured to send the traces, the metrics, everything from that hotel demo applications. So by just doing this and enabling it, and enabling those collectors, it means that we also should see the traces of the hotel demo application. So here, if you pay attention, we can see that it's going through the hotel demo product catalog. So those are the traces that are done through a vanilla OpenTelemetry auto instrumentation injected in the case of this demo. So it's not done by the Odigo's instrumentation at all. It's basically the vanilla OpenTelemetry. Same thing for metrics. Of course, this application is not generating logs. So this is why we are getting all those details. That's it for today's episode related to Odigo. I think it's a very interesting project, very promising, where without any effort you get traces, metrics, and logs directly in your own observability backend of your choice. I like the fact that they are pre-building the collector pipelines for us and have the options to customize the destination where we want to send the data to which backend of our choice. I think it could be also great once the profiling is available to utilize Odigo to also collect the profiling from the cluster to send it to the right backend. So I think there is a lot of promising things behind this project. If you enjoyed today's content, don't forget to like and subscribe to the channel. So see you soon for another episode.